One thing we do have to talk about, right, is order of operations, because you have been trained, hopefully, since day one to follow order of operations at all times when we are working with addition, subtraction, and multiplication. Not so much division here, but in there. And when we are working with the y coordinates, when you are working with the range and transforming the range, we follow order of operations. Which essentially, guys, in our purposes, means we perform the multiplication before addition or subtraction. Now, again, this comes back to that idea of an inverse. Because the b and c values, notice up here, the b and c values are inside the sign function, where a and d are outside, we are going to have to do the opposite. So when we transform the domain, the x coordinates, we must reverse the order of operations. And essentially what that means is we need to do any adding or subtracting before we multiply. And guys, this is where like 90% of mistakes happen. This takes practice. This really does. This is simple in concept, but it really takes some practice to make sure that we get this down as repetition. So before we end this video, let's look at one example here where we actually do what we just talked about above. We identify A, B, C, and D. We follow the order of operations to change the range, the y coordinates. We reverse the order of operations to change the x coordinates and actually transform the coordinates from f of x, the parent function, to g of x, our transform function. Now, one thing to remember here, guys, is that the parent function does have an a, b, c, and d. We just don't see any of them because there are ninja factors and ninja terms. So f of x equals 1 times the sign, right? There's actually a 1 there. And then there's actually a 1x. There's a 1 in front of the x. And there's actually our parentheses. We just don't see them. Minus 0. That's why we don't see any value there, because anything minus 0 is just itself, plus 0. So that's one thing we've got to be thinking of, that in our sign function, right? Remember, in our sign function, A, B, C, and D are 1, 1, 0, 0. So when we look here, when we look at this trig function here, the first question we have to ask ourselves is, did A, B, C, and D change from the parent function? The answer is, for all of them, yes. We can see here A is -3. We can see that, avoid blue, B is going to be 2. We can see that C is -pi. Remember, that is an addition symbol. In our formula, we pointed that out up here, it was subtraction. Since it changed from subtraction to addition, that's actually a -pi. And just like I think most of us would recognize here, D is what it is -1, which actually is also a change. In the initial formula, it's plus D. Now we have -1, so it's -D. All right. So if we were describing these transformationally, which we're not going to take a lot of time to do, but I'll do it once for us here. With A being -3, that is going to cause a reflection. Oops, that's the wrong purple. Sorry. Hold on. Let me get the right color purple here. So A is going to cause a reflection over the x-axis. And we're going to have a vertical stretch by 3. All right. B is 2. So B is going to cause a horizontal stretch. Nope, sorry. Shrink. Remember, it's the opposite. If B is bigger than 1, it's a shrink by the inverse of B. Well, 2, the inverse of 2 is 1/2, so 1/2. All right. C and D give us our translations. So we are going to we will translate to the left pi units, and we will translate to the down 1 unit. So if we were describing these graphically, visually, this is what we'd be dealing with. So let's talk about how we use these numbers, -3, 2, -pi, and -1, to actually do the transformations on the table here. So what we should have noticed above, guys, is that A and D affect the y coordinates. So let's look at that first because I'll be honest with you, though, that's the ones that make the most sense, ones we've worked with. What we do, remember, we multiply by A, and then we add or we subtract. Oops, that should be in gold here if I'm doing this in color coordination, trying to stay color coordinated. We add or subtract D. Since A is negative, we're going to multiply -3. And then since D is negative, we are going to then subtract 1. So we need to take all of these values here and multiply them by -3 and then subtract 1. So 0 times -3 is 0, minus 1 is -1. 1 times -3 is -3, minus 1 is -4. You get the idea here. Anytime it's 0, it's -1. Now, -1 times -3 is +3, minus 1 is 2. So we just now performed a reflection over the x-axis, a vertical stretch by 3, and translated down 1 unit. We did all of that by multiplying by -3 and subtracting 1 from the parent function coordinates 0, 1, 0, -1, 0. All right. Now, B and C affect the x coordinates, and this is where we've got to again think a little bit more here, because the order of operations is reversed. We are going to first add or subtract C, and then I'll shrink this down here. Then we're going to multiply by the inverse, I should say, by 1 over what B is, the absolute value of B. All right, let me shrink that down a little bit because I couldn't fit that in here. All right, so what that means for us is that we are going to subtract pi from each of these values, and then we are going to multiply by 1/2. So 0 minus pi is -pi, times 1/2 is -pi over 2. All right, and guys, I'm going to kind of go through the arithmetic here of the fractions a little bit quickly, because we should be able to handle fractions here. But -1 pi, or pi over 2, minus -1 pi is going to give us -pi over 2, times 1/2 is going to give us -pi over 4. And I'll tell you what I'll do. Outside of the video, I'll do the arithmetic over here off to the side. I just don't want to take time in the video to do that right now. Pi minus pi is 0, times anything is 0. 3 pi over 2 minus pi is +pi over 2, times pi is pi over 4. And 2 pi minus pi is 1 pi, times 1/2 is pi over 2. So we just performed a, I'm sorry, my color coordination in my OCD, I forgot to do that. So let me change, what did I make that color? That was red. So let me make this red here, and then let me make all of these blue, because these are our new transform functions. There we go. So we just performed a horizontal shrink by 1/2 and a translation to the left pi by doing this. I think you can see, guys, that translating on the table is going to be way less confusing than trying to translate visually on a graph. And there we go. We have our transformed coordinates for g of x, and we can move forward. All right, so in the next video, guys, we'll actually look at the parent function in a little more detail, and then look at some examples of how we actually go all the way from an equation to a table to a graph and the characteristics. We'll see you then.